Okay, now how the communication happens between a name node and a data node, right? Let me explain you on the whiteboard. Let's say I have a name node, I have a data node, right? First of all, what I will do, first of all, I have to format the name node like any other file system, right? Whenever we create a file system, we format it. So name node has a file system HDFS, right? Which is laid across all the nodes in your Hadoop cluster. So first of all, what I have to do is I have to format the name node. I will execute a format command, right? So I will see what command it will be, but I will format the name node. The moment I format a name node, it will give it a cluster ID, right? It will be a randomly generated number. Let's say it gave 1, 2, 3, 4, 5, 6, some number it gave it, right? This is the ID, it is the cluster ID, which will decide which cluster. This is kind of an identity of your cluster. Now, I do not do any format on data nodes. I will simply go start a data node and I will tell data node, this data node, let's say D1, where is name node. I will tell it where is name node. I will give the address of the name node in a config file. This name data node will go and try to register itself with the name node. Correct? So if, as I said, these all are new nodes, this data node will not have any cluster ID because it's a new machine which we have built. So what happens when a request is sent from a data node to register with a name node? First thing name node will check is whether this data node was already part of any other cluster, right? Means how it will check? It will check, ask the data node to give the cluster ID. If this data node was never part of any cluster, it is a new machine, so obviously it will not have cluster ID. So data node will say, I am new, I do not have any cluster ID. So name node will say, okay, fine, then you can join me. It will give the cluster ID, same cluster ID. So now this data node will become part of this cluster because now it will also get a cluster ID, same for all. But let's say this machine which I brought a data node, let's say data node 4, was already part of some another cluster and had some cluster ID, let's say cluster ID 7689 something. It goes and tries to register itself with the name node. Name node will say, give me your cluster ID. It will send because it has. Name node will say, no, cluster ID does not match. It will fire a shutdown command. Name node will fire a shutdown command on the data node and this data node will shut down. So this is all safety mechanism built into Hadoop. Otherwise, let's say somebody might have mistakenly added this data node into a wrong cluster and it will wipe your entire data. So it is a safeguard mechanism against that, right? So it will not let you do that. So this is what I'm explaining here. So how the communication happens? First is data node will do a registration. As I said, it will say, okay, I'm a new node or my cluster IDs matches and all. Second, it will send a heartbeat every few seconds, which is 3 seconds. It will send block reports and it will also acknowledge the blocks received, right? What does it mean, right? Let me explain you this also. Let me clear it. Let's say I have a name node and I have a data node. First thing is it will register with the Hadoop cluster, right? First thing is it will register with the Hadoop cluster with the name node. First step is register. So it got a cluster ID, became part of the cluster, it joined the name node. Second thing, every few seconds it will send a heartbeat to the name node. Blue line is a heartbeat. Heartbeat is sent every 3 seconds from the data node. It is kind of giving it attendance, right? All those people who are from infrastructure background, it is similar to a cluster heartbeat, right? So the node is telling I am alive, I am there. Every 3 seconds it is telling name node I am there, I am alive, right? This is 3 seconds, every 3 seconds. Another thing which it will do is, let's take green color. It will send a block report. Each data node will send a block report. This is block report. What is block report? It will tell what blocks I have, what is the disk size I have, right? This disk might have, let's say, 1 terabyte disk. This might have, let's say, 4 terabyte disk. This might have, let's say, 10 GB disk. So it will tell the name node, I have so many blocks. So this block, which I'm talking about, the green line, it will send a block report on 3 occasions. First time when it boots, right? First time when the data node boots. I build my new cluster, start my data node, or even when I restart the data node, whenever the data node daemon comes up, it broadcasts or it advertises, not exactly broadcast, it advertises all the blocks it has. Second time, it does periodically, which is configurable, means I can say after 1 hour or after 4 hours or 6 hours, again send the block reports. Third will be whenever a name node asks. Name node can ask a data node saying, give me the block report, right? 3 times it will send a block report. Let me see anybody has any question and then I will go a little bit deeper. Any questions you have up till now? Okay, so no other questions. So let me explain you a little bit deeper. So when I say block report, right? Obviously, like we cannot cover everything in the course, but there are a lot of details which go into it, right? So you will get to know many things when you actually work in a production environment, and you will say, "Oh, I was never aware this also happens," right? But let me give you some little bit idea about it. When does a block report is what type of block reports are sent? First of all, as I said, data node will advertise the blocks it has 3 times. One, when it boots, it will send a complete report of the entire block it has. Second block report it sends periodically, means it is a configurable parameter. By default in Hadoop 1, it is 1 hour. In Hadoop 2, sorry, H2, it is 6 hours, right? I will show you all these parameters. Do not worry, right? Where all these parameters go, how you configure and all, everything we will see. So periodically, so every 1 hour, it will send a block report, but it will not be a complete block report. What block report it will send? Only the delta, whatever blocks have changed. It might be new additions, it might be deletions, it might be corrupt blocks, right? Only delta it will send. Third will be whenever a name node asks, name node will ask a data node, send me a block report. And then name node will say, I want a complete or a delta report. It can send either. So there are 3 occasions when a block report will be sent. Now, little bit more details. If you might have noted, you might be thinking I am just drawing an arrow like that. I'm saying name node, I'm saying data node, D1, D2, D3, and my arrows are drawn in this direction, right? It has a meaning actually, right? It is not that I'm just drawing because I'm feeling it comfortable drawing upwards. What it is telling, it is telling me the direction of communication. What it is telling, that data node is the one which always initiates the connection in terms of communication between them, right? Because I may have thousands of data node, name node is only one. So if I start doing pull mechanism, for example, if I would have coded this way, let's say I have written a Java program. Anyway, this works on RPC calls, right? Remote procedure call, the protocol which talks between them. Let's say I'm a developer and I write this infrastructure first time. What I say, the code which I write over this, right? So anybody who is from networking programming, they will know that this concept is called RPC stubs, right? Skeleton stub model. Skeleton stub model. So I might have written, I am saying to name node, go to each data node, fetch the blocks, right? If I have 2 3 data nodes, it's fine, but my cluster can be 3000 node, 4000 node. So I'm telling a single node to go to 4000 nodes, fetch the report from all. This will be a bottleneck in my case. I am not doing that design. So what my design is, I'm doing a advertisement from data node, and name node is just listening. It is listening for all the traffic which is coming to it, right? Now name node, data node, D1, D2, direction is this. Now I'm also said that every 3 seconds this data node will send a heartbeat to the name node saying I am there, kind of attendance. In this heartbeat channel, right? If name node has to fire any command, it will fire, right? You got the point? Name node will not open a command channel by itself, right? There are some cases it will open. I will talk that little bit later, but for the time being, name node will never open any command channel to a data node. What it will do, to save on the overheads of opening and a closing file, what it will do, because heartbeat is coming every 3 seconds, it's not a long time. When a data node comes and opens a heartbeat channel every 3 seconds, on the same open channel, it will fire a command to the data node. Any operation command. Command could be shut down data node. It might ask a data node to replicate a block, delete a block, right? Commands could be anything, right? So this is important to understand, right? From a design perspective. A lot of things are there. I will show you some production use cases. When your name node will fail to boot up, if I start all my nodes, let's say I have a 3000 node cluster and I start all in one go, my name node will hang, right? So how we do that, why it hangs, we will look at all those details, right? But this is important to understand, right? What is the communication path? What is the steps it does, right? So this is what I explained you. First step is it will do a registration. I explained you all this which is given in the slides. If name node is new, if the data node is new, it does not have a cluster ID, it can straight away go and join, right? So I will show you all this on the system, right? Do not need to worry where it file is and all, right? Data registration process. Then heartbeat process. So as I said, name node will fire any command in response to the open channel. It might say replicate, invalidate means delete a block, or ask for a block report. Datanode sends the block report, step 3. As I said, when it starts, every hour or 6 hours in Hadoop 2, or whenever a name node asks for it. Point 4, Datanode will also acknowledge any blocks it has done operation on. For example, there might be a block written to a data node, but it has to acknowledge it to the name node saying I'm done with my operation, or delete a block, it will update the name node, right? So it updates the name node, other data nodes, or a client. The communication channel is RPC. Client does not talk on RPC channel. Why it does not talk? There is also a technical reason, right? So we will go into in depth of this, right? RPC channel is for communication between the name node, data node, job tracker, task tracker, all these daemons. But data flow does not happen on RPC. Data flow always happens using REST API, right? Because it is light, just do a post and get. What does it mean? Now you will ask how it can do a REST API when there's no web server. So I will come to that. Each daemon, name node, data node, job tracker, whatever we run, will have a web server built into it, into a daemon. We don't need to configure it. It is not an Apache web server or a Tomcat web server. They are full-fledged web servers, right? These daemons, they have a simple JT server written in Java, which can simply do post and get request. So your data transfer will always happen on that channels, right? But your communication saying talk, shutdown command, block report, talking about each other's daemons happen on RPC. So these are the key points. Namespace ID or the cluster ID, right? It has two names. Namespace ID we started calling in kind of Hadoop 2, but it is the cluster ID, right? It's the same thing. Is assigned to a file system when it is format, and it does not change throughout the life of the cluster. If I change the cluster ID, my services will shut down because they will not identify that I am part of this cluster. Heartbeat will be done, right? As I said. So why a handshake is done, right? Why a data node register? As I explained you, to make sure that it is not by mistake attaching to some wrong cluster. Otherwise data will be deleted. And it is also making sure data node is also running on a compatible software version. It is, should not be that I'm running name node with 1.2 version and data node with 2.2 version. It will not let you talk, right? It will fire a shutdown command to safeguard against human errors. Obviously human errors you can do, you can still do rm-rf on a data, right? But from a Hadoop perspective, it is trying to safeguard the common mistake which an engineer might do. Cluster ID will be stored on all nodes so that they know which cluster we are part of. Right? As I said, any new data node will be allowed to register with the name node and receive